In this video, we're going to talk about substitution ciphers. So the first thing we're going to do is define both monoalphabetic substitution ciphers and polyalphabetic substitution ciphers. Then we're going to concentrate on monoalphabetic substitution ciphers and show a general way of defining keys for these ciphers. And finally, we're going to show how we can have simpler keys for certain types of monoalphabetic substitution ciphers, particularly ones with a simpler structure. All right, so let's start off by defining what a substitution cipher is. All it is a cipher where each character in the plain text is represented by a character in the ciphertext. So the ones that we are most familiar with are the monoalphabetic ciphers, and those are the ones where each character in the plain text is always represented by the same character in the ciphertext. So for instance, if you were to run into a ciphertext and you had an R in two different places in the message, we may not know what letter R represents, but we know that the R represents the same letter in both instances. However, this is not the case in the other kind of substitution cipher called a polyalphabetic cipher. And that is a situation where each character can be represented by more than one character depending on where it shows up in the message. And of course, this has to follow rules that are agreed upon by the sender and recipient. Otherwise, the recipient's going to have trouble decrypting that message. And we'll talk about that a little later when we talk about the Vigenère cipher. But for right now, we're going to focus our attention just on the monoalphabetic ciphers. And those are the ones that behave just like the cryptograms that we were working on before. So here's what the keys might look like, right? So there are certain ciphers where this is not necessarily needs to be the case, but a key is pretty much has to be a table that matches each letter of the plain text with its corresponding letter in the ciphertext. And this is for monoalphabetic cipher keys. So here's an example. The top row of each of those tables is the plain text, and the number and the letters that are just below them are going to be the corresponding letters that you use for the ciphertext. So for instance, if I want to encrypt "I am hungry, please send food," to encrypt that I, I'd look on the top row until I found the I, and then right below it is a U, so I'd use the letter U for the word I. And then for M, if I'm looking for A, right below that is an X, and for M, right below that is an I, so for M is going to be encrypted XI. We keep on going with the rest of the message. Then we remove the punctuation and get rid of the spaces, and there's our ciphertext. Now, if someone sends us back the following message, right, that's ciphertext, and we want to decrypt it, then we just go the other way. We look on the bottom rows where the ciphertext is and look above it to see what the plain text is. So for instance, for W, we look on the bottom row for W, see that there's an H right above it, that's going to be an H. We look for E right above, that's on, let me see, where is the E? Oh, there's the E. Right above that is an O. Jeez. And so we encrypt the E with O, and we keep on going. The V, let's see if I can get confused on that one. The V has a W right above it. We just keep on going, and we end up with this as the plain text, and then we kind of look at it and figure out where the spaces should go and where the punctuation should be, and we end up with "How about a sandwich?" So that's generally how we have monoalphabetic cipher keys and how we use them to encrypt and decrypt messages. So in certain monoalphabetic substitution ciphers, we do not necessarily need an entire tables, especially when the rules are a lot more structured. And an example of this is we'll generally call it a shift cipher, but it's also called a Caesar cipher as well. And it's usually called a Caesar cipher in your book, so just heads up about that. So in this situation, our key is actually not a table, but just a number, some number K, right? Now, if we want to encrypt a message, what we do is we take each plain text letter, we look K letters down in alphabetical order, and that is going to be the corresponding ciphertext. So that is all fine, except what happens if going K letters down alphabetical order takes you past the letter Z? No big deal. You just cycle right back to the beginning of the alphabet to A, and then keep on going. So let's do this with an example. So here our key is going to be the number 5. And so if I want to encrypt the message, "Do you want to play?" Well, let's see how I'd encrypt that D. Well, I go 5 letters forward in alphabetical order. So you start with D and then E, F, G, H, I. So D would be encrypted with I. You do the same thing with O. So 5 letters past O is P, Q, R, S, T. So you'd replace the O with T, and so you end up with IT for do. Now, for U, our Y is going to cause us a little bit of problems, right? Because Y is going to require us to go past Z, but that's no big deal. So we go one step from Y to get to Z. Our second step is going to be to A, and then our third, fourth, and fifth steps are going to be B, C, and D. So you replace the letter Y with the letter D. With O and U, that's the same as what we had before. You can end up with D, T, Z. For the rest of them, they're pretty much exactly the same. Note that for W, we have 5 letters past W is X, Y, Z, A, B. And that's how we end up with B as the first letter of that one. And then the Y in play is just like the Y in U. Y, Z, A, B, C, D. So we end up with D. Now, if someone sends us the following, and then we take out the spaces, take out the punctuation, and that's going to be our ciphertext. Now, if someone sends us back the following message, DJX, we do exactly the same thing, except now we go back in backwards alphabetical order. We reverse that process. So we're going to subtract 5. So if we start with D, we're going to have to go back 5 letters. That's going to be complicated because that's going to take us past A. So if we go back, we go C, B, A, and then back to Z for the fourth one, and then back to Y. So D gets decrypted as Y. For J, we just have to go backwards 5. So J is I, H, G, F, E, right? That's going back 5. So we get Y and then E. And then for X, we go back 5. So X goes back 1 to W, then V, then U, then T, then S. So that decrypts as Y, E, S. And so I guess they want to play. So that just gives you an example of a cipher where we don't necessarily have to have a really complicated key. So now I think you're ready for the monoalphabetic substitution. That's the activities that are included with this video.